two values for a single value of x, and in B these four are different from each other. They are not same. So if A suppose we have f a here to f of 2, and it will map to, suppose we have here 3 or 4, f of 2 can be equal to 3 or and 4 at the same time. So basically this is not even a function. In the second case, we have 5 elements in A and 5 elements in B. Here first elements map to second elements of B, and second maps of A maps to first element of B, and the third and fourth elements of A are mapping to the third element of B. This can be possible. Here an example of this is like if we have fx is equal to x cross x into x and x and f. One example, fx is equal to x into x, and another fx is equal to x 2x, and we have the value of x is equal to 2. So 2 into 2 is equal to 4, and 2 plus 2 is also equal to 4. So the all of them having both functions can map to a single value in B, and the fifth element is mapped to 4 elements. So this is a general function. Here B can have many A, and the third one, we have each element of A mapped to each exactly one element of B. What we have, what I have showed you in earlier slides. This is an example of injective functions. This is not a, I don't know whether you know about the surjective function or not. In surjective functions are those in which each the entire elements of A are mapped to exactly one element of B, and there is not any element which is left over. So this, the third example is not a surjective. And in fourth, we have 5 elements in A and 4 elements in B. Here each elements of A is mapped to each elements of B. So there is no element is left over. So this is an example of a surjective function, but the third and fourth elements of A are mapped to a single element of B. So 2 elements of A have mapped to a single element of B. So this is not an example of an injective function. In the fifth example, there are 5 elements in A and 5 elements in B. Each element in A is mapped to each exactly one element in B. So this is an example of injective and surjective functions. Next, I will talk about the integrals. Integrals are mainly of two types: definite and indefinite integrals. Definite integrals are defined over a definite limit, like fx is equal to a to b f of x dx, where f of a to b f of x dx can be written as fx a to b is equal to fb minus fa. So basically integral is a integral of a function can be represented as the area under the region bounded by the curve going over the graph. So here we have a function fx, and it is moving like this, and this is the area that is coming under the curve. So this portion will be a positive because it is over the x, and this will be a negative because this is in negative over x, means that when we do when we calculate the fx, it gives a positive value of y, basically the positive sign defines that. And if we calculate with the value of fx in this area, we will get a negative value of y. And there is another type of integrals, indefinite integrals, where we don't have any definite limits. These are the basic integral that you know, already. You have learned all of these in your class 12 or class 11 12. These are the list of integrals that we encounter normally. Integrals of rational functions, integrals of irrational functions, trigonometric functions, inverse trigonometric functions, hyperbolic functions, inverse hyperbolic functions, exponential functions, logarithm functions, and Gaussian functions. I hope you all know about these. Here are some types. Integrals with a singularity. Here we have a function 1 over x, where x can be 0, then it will be a singular function. So if we integrate this, we will get a natural log of x plus some constant, and this constant value depend on whether the value of x is positive or negative. So we will have two constants depending on the sign of the x. And the exponential functions, e to the power ax dx is equal to 1 by a e to the power ax plus c, and f dash x e to the power fx dx is equal to e to the power f of x plus c. I hope that you all know the basic multiplication rule of integrals when we have two functions in the same integral. We use like if we have an integration of f of a and f of b dx, where a and b are f of a and f of b are a function of x. So it can be written as the integration of f of b minus integration over integration of f dash a, and then the derivative of f dash b, and the whole integration of the remaining quantity. I forgot to add the equation in this. You will find that in your class 11-12 book easily. There the another type of function are logarithmic function, like ln natural log of x dx is equal to x ln x minus x plus c, and log of a is the base, like a can be 2, 10, or e exponential means is equal to x log ax minus x and of a plus c, x ln x minus x over ln a plus c. And you all know that the trigonometric function, integers of trigonometric function written here. Just go through all these. Now in inverse trigonometric functions, arc sin x dx, arc cos x dx, and arc tan cot, arc sin, arc sec, arc cosec. These all integrals will be a prerequisite for this course. So you all revise them. Hyperbolic function, sin hyperbolic of x dx is equal to cos hx, and Okay. Cos the hyperbolic of x dx equal to sine hyperbolic x plus c. Go through all these. And then inverse hyperbolic functions arc sine x dx x arc sine h x minus square root of x square plus 1 plus c. And these are some other important integral that you know. Actually, you should carry out the integration by yourself so that you can learn the solution of these integrals. These integrals are very useful in solving tedious solutions, tedious equations. Like when you will be solving Fourier series, you have to remember some integrals to carry out the solution faster. In the first integral, we have a exponential integration of an exponential function with another square root of another function having square root of x, which gives us after solving 1 by 2 under root of pi. And the next one is a Gaussian function, which gives us the solution 1 by 2 square root of pi by a. And the third one is also type of Gaussian function with another function having x square. X square e to the power minus a x square dx is equal to 1 by 4 under square root pi by a3 for all a greater than 0. And the next one is a generalized equation. So you can carry out all the solution in a faster way, which having a representative form similar to this, where n can be a real value. So a continuous function. A continuous function is a function that does not have any abrupt change in its value. Like it doesn't have any discontinuity over over a period. So we can say the function is continuous in this range if it does not have any discontinuity in a defined range. So here are some examples, like f of x is equal to x square, and the second one is f of x is equal to x cube. Third one is f of x is equal to sin x. Fourth one is f of x is equal to e to the power x. These are the examples of continuous functions. Here there are two examples of the discontinuous function. In the first example, we have f(x) is equal to x square when x is smaller than or equal to 1, and f of x is equal to 6 minus x when x is greater than 1. So basically, we have a discontinuity at x is equal to 1 in this particular type of function. In the second function, we have a discontinuity in the range from 0 to 1. This is represented as here. The next one is machine and mechanical systems. A machine is a mechanical structure that uses power to apply force and control movements to perform an intended action. A machine is something that makes our work easy, or we can use in various actions to maximize our force. Like in case of plier, we can cut wires or do other things, and in case of nail cutter, we cut nails by just pressing our hands over it. And in case of drones, we can fly it using some DC motor and a code programmed over some controlling board. In case of cycles having gear, we have cogs and a cycle chain which are running through the cogs, and the crank, and pedals. When we move the pedals, it will translate into a motion, and that makes our life easy. And the next is an example of a transducer that transmits a signal, in this we have a piezoelectric crystal that converts the electrical energy into mechanical energy that will result in in generation of some mechanical waves which moves through the medium. A mechanism is a device that transforms input forces and movement into a desired set of output force and movements. Mechanism generally consists of moving components that includes. Uh, in the previous example, in case of a cycle, there is a backshift gear. If if we press the button to shift the gear, it will turn down and change the gear. This is a type of a mechanism. Uh, It includes gears and gear trains, belt and chain drives. In belt and chain drives, in case of pulley, where we have to lift heavy weights, cam and followers, linkage, friction devices such as brakes and clutch, structure components such as frame, fasteners, bearings, springs, lubricants, and various machine elements such as spines, pins, and keys.
Okay, so I guess that's a very simplistic approach of explaining electromechanical systems. And if you guys were concentrating, you may be finding it very obvious thing and